And with it being 11 o'clock, we will go ahead and get started. Thank you for joining us today for the roof membrane selection webinar. I will get to introducing our panelists here in a few minutes, but first I want to introduce Benchmark. One thing I do want to point out is at the bottom of the screen there, you do see a QR code. If you take your phone, turn on the camera, and hold it up to that code, it should go ahead and take you right to the Benchmark LinkedIn page. We'd love for you to connect with us. We share a lot of great advice there. So please go ahead and give us a follow. So a little bit about Benchmark. We are a roof and pavement consulting company that was established in 1983. We're an independent company. We're not tied to a manufacturer or contractor. We truly are out there to give our clients the best advice that we can. Some of our services include roof and pavement evaluation, design and bid services, as well as construction phase services. Our offices are in Cedar Rapids, Iowa, Waukesha, Wisconsin, as well as we have consultants scattered throughout the United States, including Jennifer, who is down in Alabama today. So now to introduce our panelists. Up first, and once again, we do have the QR codes at the bottom of the screen, so you can go ahead and hold your phone up there to connect with any of the three panelists today. Up first is Andrew Reynolds. He is a senior consultant, professional engineer, and a partner at Benchmark. Next, we have Jennifer Steffen, who is a senior consultant and registered roof consultant. And finally, we have Chad, who is also a senior consultant, a registered roof observer, as well as a partner with Benchmark. And with that, we're going to go ahead and we'll turn this over to Andrew to start the discussion of roof membrane selection.
All right, thanks, Ben. So I'm just going to quickly kind of go over different types of membrane and options that you'll have within those membranes. First is Thermoset, which is pretty much limited to EPDM these days. You might know that more as a rubber roof. It's black. Typically, you can get it in white. It's typically non-reinforced, but you do have an option to get it in a reinforced option, which you would usually use for a mechanically attached situation. It's a pretty common roof, especially in the northern climates. And then moving on to thermoplastics, which I'll just quickly go over. Chad's going to go over these a little bit more in detail in a couple slides. Typically, you're going to see PVC, KEE, and TPO, with TPO being the most popular option at this point. These sheets are, you might hear them referred to as vinyl sheets. They're reinforced. Typically, you'll see polyester or fiberglass mats. You can mechanically attach these, adhere them, induction weld them. You can put them in hot asphalt. There's all sorts of options you can do with these. But again, Chad will touch on those a little bit more. Moving on to asphalt-based systems, starting with built-up roofing. Built-up roofs have been around for decades and decades, probably hundreds of years. They're kind of dying out a little bit for a couple of reasons. Asphalt quality is actually going down. They're just able to get more stuff out of asphalt, so the quality that's left over for roofing it's kind of going down a little bit. But the bigger portion is labor. There isn't labor out there to install these roofs. As single-ply roofing has gotten more popular, the training and labor for built-up roofing has kind of diminished. A couple more things about built-up roofs. You're typically going to see them right now installed with fiberglass felts, typically in a 3 or 4 ply system, and they're going to have some sort of surfacing, whether that be an aluminum coating or a flood coat and gravel. You can have smooth surface on your built-up roofs. It's just not typically seen. Modified membranes kind of were born out of built-up roofs. They were developed in the 60s in Europe before transitioning over to the States. There's 2 types, APP and SBS, and the only difference between those are the types of modifiers that are used to manufacture the sheets. SBS is a kind of a rubber modifier. APP is a plastic modifier. These are typically installed in a 2-ply system. They're more popular than built-up roofs. They're a little more expensive, but it gives you a multitude of options on how to install these. They can be put in cold process adhesive, which is probably the most popular right now, torch applied, or you can install them in hot asphalt. There's some self-adhering sheets along with that, but they're not popular yet. Going on to metal, your 2 differences are going to be architectural and structural panels. It's pretty simple. Architectural panels have a structural deck beneath them, whether that's a steel deck or some sort of plywood or OSB sheathing. Uh, the panels themselves don't carry any structural load. And then obviously on the other side of that is a structural metal panel. You're going to see these usually installed with continuous clips, but these panels, you walk on them and they're attached right to the structure of the building, so usually to a purlin system, and they can actually carry a load. They're going to carry your snow load, they're going to carry your wind load, all of that. So that's your main differences between panels. They're available in a variety of finishes. Galvalume panels are very popular. You can get pre-finished panels that are painted in a variety of colors. So there's a lot of options out there for these. Other notable roof systems, I'll just quickly go through these. SPF or spray polyurethane foam. This is typically used as a recover system. Pretty much you have an existing surface. If say it's a metal roof, you can come through, install spray polyurethane foam on it, put a coating on it. It could be an acrylic coating, a silicone coating, a lot of different options. It really depends on what you need. The only issue with these roofs are they're very dependent on temperature, humidity, and wind during installation. So it's really difficult to get that scenario perfect. Steep slope roofing, it's obviously a very popular type of roof. A lot of different ways to install it, a lot of different materials, but we could spend at least another hour just talking about steep slope. So we're just going to stick to low slope. CSVE and coal tar pitch, you still see these roofs. You don't typically see them being installed anymore, and that's because there's really only one manufacturer that's still producing Hypalon or CSVE, and there's really only one manufacturer that's producing coal tar pitch materials. They've just kind of gone by the wayside, and it's just a really small percentage, so we're not going to cover them in depth here. And with that, I think I'm going to throw it over to Chad, and he's going to talk about thermoplastics and thermosets.
Thanks, Andrew. Yeah, for the thermoset and thermoplastics, the biggest difference between those is if you could look into the name thermoset, that material is already set. It cannot be reactivated and or welded. And thermoplastics, if you think of a plastic, that can be activated through heat. It can be melted and welded seams. So going back to the thermoset membrane and the adhered seams, there's various ways those seams can be adhered. Early on, there were glues and adhesives that were used, and usually the lowest guy on the totem pole was the one cleaning the sheet and using that. As those systems have evolved, there are now seam tapes. They can be field applied or factory applied. And then also there can be some chemical bonding, with Andrew talking about the CSPE and Hypalon. When it's fresh, it can be almost welded, but it cures out very quickly. So the way that it was typically installed was through a chemical that would be wiped onto the seams, kind of like a primer, the two sheets put together, and then they would chemically bond. So out of the thermal sets, EPDM is I'm going to say the big boy on the block. It is the most popular, especially in northern environments. There are the CSPE Hypalons. Burke Industries is still a manufacturer of that. You don't see that as often anymore. The other couple out there, PIB is one. It was a good sheet for its time. You just don't see that out too much anymore either. The thermoplastic membranes, they've really come a long way. They hold a large market share nowadays. You have your PVC, polyvinyl chlorides, multiple manufacturers of those. It has been on the market for a while. KEEs, there's one true manufacturer, if you follow ASTM anyway, one true manufacturer of KEEs, but in the recent years, there's a lot of manufacturers who have been blending KEE with PVC, and even the original manufacturer who made KEE also has a sheet now that is KEE on top and PVC on the backside. The new biggest kid on the block that Andrew alluded to is TPO, the thermoplastic olefins. That has a very large market share, and I think that, along with cost, with the EPDM, they are the lowest cost per square foot, so they seem to get a lot of attention, especially in new construction and large facilities.
A turn now. With all the different membrane types that we've talked about, you can imagine there are a variety of ways to attach them. The most common methods are with adhesives and mechanical fasteners. For most single-ply membranes, the attachment options include adhesives, mechanical fasteners, and induction welded fasteners. With EPDM, TPO, and KEE membranes, they can also be loose laid and held in place with ballast and pavers and stones. Hot bitumen is commonly used as an adhesive for the modified bitumen and built-up systems, but there's also a couple of single-ply systems that can be adhered with hot bitumen. Although we don't see them as often anymore, there are still a couple of torch-applied mod fit systems out there available, and those are pretty robust. If you can find the qualified skilled labor to install them, they are a good system still. We've also got metal roofs that are, as Andrew said, attached with either concealed clips or through fasteners that, to fasten those down to the roof deck or the purlins. The rates of attachment and methods of application will vary depending on the components of the roof system, the building configuration, and the wind uplift pressures that you need. All of the different membranes on the market have their pros and their cons. As we evaluate a specific roof project to determine which membrane is the best solution, we look at a number of different criteria. The evaluation must take into account site-specific parameters, code requirements, location, logistics, and a host of other things that might be particular to that specific roof. This chart shows a summary comparison of the most common criteria. They're not listed in any particular order of priority. But I'll just go down the list and talk about each one of these briefly. Depending on your facility and your operations, the chemical resistance for the roof membrane may be a primary criteria. Chemical resistance covers anything from exhaust discharge, salt deposits, aircraft fuel vapors, fats, oils, and grease from cooking equipment. As you can see, the PVC and the KEE offer an acceptable level of chemical resistance to some types of exposure. TPO and modified bitumen offer some marginal chemical resistance to different types of chemicals and exposure. The resistance is very dependent on the type of chemical. So it's important to get that information and talk to the manufacturers about that specific roof section during the membrane selection so that it can be evaluated at that point. With special treatment, surface coatings or treatments around those grease producing equipment, the modified bitumens and even PVCs can hold up to different levels of chemicals and do a pretty good job. Durability is also a major factor for all of the roof systems. The roof membrane must be able to withstand the typical and expected activities on that roof. Durability takes into account things like puncture resistance, UV stability, flexibility, aging. By nature, single-ply systems such as EPDM and PVC are not as durable as the reinforced or multi-ply systems. The TPO systems are the least durable due to their low puncture resistance, UV degradation, and loss of pliability as they age. Still a good membrane, but just not as durable. Solar reflectivity can be a deciding factor in some climate zones and jurisdictions. Different membranes offer better reflectance than others. Your bright white single-ply membranes are going to be your best reflectors, but there's also some modified bitumen membranes with white granules or quartz granules that offer good solar reflectance. The expected service life of the membrane should be evaluated and discussed with the client during the early stages. Most of the roof membranes out today have about a 20-year or better service life, with the exception of the TPO membrane, which is often typically only 15 years. You'll want to marry that expected service life with the capital planning budget. time frame for the client so that you make sure that you're designing a roof that will last the anticipated service life that the client is expecting. Whether a roof membrane or system is recyclable is a factor for consideration. I think this is part of all of our responsibility to protect our planet, to reduce landfill waste, and preserve our resources for future generations. Recycling the membrane or components is also key for some of our lead clients. The most common single-ply membranes and metal roof systems are easily recycled. Now we get into hail resistance. It kind of goes hand in hand with durability. Taking into account each roof's location and typical anticipated weather, hail, snow loads, you've got to factor in all of those things in choosing a membrane. There are numerous systems that offer moderate to severe hail resistance, and the list of very severe hail assemblies is growing as well. Most of those membranes are going to need a solid cover board within the assembly to increase that hail resistance. Modified bitumen membranes provide the best, the highest level of hail resistance, although with specific cover boards, some single plies are offering very severe hail-rated assemblies now too. Metal roofing provides the least resistance to hail because of the relatively thin panel, and oftentimes it's not fully supported by the sheathing. That there might be clips or there might be an air gap underneath the metal that promotes denting or damage to that metal field panel during a hailstorm. Another factor for consideration is the ease of installation and the ease of repairs. Many of our projects have time constraints, logistics, or site-specific challenges, and finding manpower that is skilled and qualified can also be a challenge in some of these places. The single-ply membranes are definitely the easiest to install, and as Andrew noted earlier, they have the largest labor pool of skilled workers in the US right now for the single-ply market. Single-ply membranes also offer the best resistance to degradation caused by ponding water. We try in the design phase to mitigate ponding water by adding crickets and positive slope, but in some situations that's just inevitable. So for those minimally sloped re-roof situations or where ponding is known or you can't get away from it, we want to choose a membrane that can hold up in the long run and can withstand that ponding water. Single-ply membranes will be your best solution under ponding. In fact, some are even designed to be pond liners and be fully submerged all the time. Our last item on the chart is cost, but it's definitely by no means the least important. It would be very easy to say that the most expensive option is always the best, but that's not often the case. It would also be easy to design a totally awesome, really expensive roof, but if it can't be built, then your effort's wasted. So selecting the best membrane that will provide the expected performance, resistance to the elements, and fit within the budget is one of the keys to a successful project and a long-term relationship with your client. TPO and EPDM membranes are typically the least expensive. PVC membranes are slightly more expensive than your TPO and your EPDM, and your KEE membranes are going to be the most expensive single-ply system. The metal roof systems are generally in the middle of the cost range compared to the single plies. And then you've got your multi-ply, modified bitumen, and built-up roofs as the most expensive to install. I'm going to kick it back to you.
Yep, and actually we get a question and I think is worth going ahead and answering while we're still on this slide. And they were asking, what is the definition of durability? And so I'm going to first kind of answer the kind of explain the intent of this chart, and then I'm going to give it back to the panel to kind of discuss how durability is tested for materials. So the idea with this slide was to try to boil down a lot of different standards and calculations for a huge variety of materials. Every manufacturer of EPDM, for example, will have slightly different test results. And so this was our best attempt at getting those to boil down in something that's a little easier to digest. So things like durability, solar reflectivity, hail resistance, chemical resistance, there's tests by ASTM that will actually set the standards for that, as well as our years of experience having overseen the installation of a lot of these membranes. It's kind of a summary of all those different aspects. But would somebody on the panel like to kind of discuss some of those ASTM tests specifically on durability?
Yeah, with the durability, going back to that, thank you, Ben. We're looking really at standard, sheets, and we'll just start with EPDM. EPDM goes anywhere from 45 mil up to 90 mil sheets, and then some say they're thicker depending if there's fleece back or reinforcement on them. So depending on what type of membrane, how thick the membrane is, you're going to have different durability of results. Or even if you would do a hybrid type system, you can do a couple layers of modified with a single ply on top, which then increases that durability as well. So this was just a general durability of the basic membrane. So hopefully that answers a little bit of that question. But if further answers are needed, feel free to reach out to us, and then after the webinar, we can get in touch with you one-on-one and explore that a little bit farther.
Perfect. And there's actually another question that came in, and they're asking specifically about recyclable, that line item there. So Jennifer, why is having a membrane that's recyclable an important aspect to consider?
I think it's important because we have a duty to make sure that we are being good stewards for the future generations, not just taking care of ourselves now, but taking care of that roof long term. So whether those components are recyclable or whether we're creating more landfill waste, I think is an important thing to consider. Also, if you think about recycling, if they're able to recycle that PVC membrane and create new PVC membrane or new PVC products, even if it doesn't go back into the roofing industry, we're contributing to paying it forward. We're reducing that load on our planet. So I think it's an important consideration. If for some of our clients, I've been on a couple projects where we've had some extreme recycling, a zero landfill project, or some extreme recycling responsibilities in order to maintain their LEED coverage, and recyclability is a major key for them.
Very good. So at this point, we're going to go ahead and just kind of summarize all that information that we have collected. And so at this point, how do you know what membrane to use? And the answer is every situation is unique. You really have to consider your specific facility, environment, all the different parameters, and try to figure out what's the best solution. And at that point, go to the individual manufacturers and verify their specific products meet the needs that you have. And so at this point, what we're going to go ahead and do is kind of step through several scenarios. So these are just kind of sample projects that were put together for us to consider. And what I'm going to do is I'm going to run through the scenario and ask our panel to think through how they would choose a membrane for the project. And one thing to note is roof membrane selection sometimes is driven by the total system. And so some of these, there may be conversations involving the insulation, the attachments, because those are all important things to consider as you are selecting your membrane. So for scenario number one, this is a food production facility in southern Texas. They manufacture fried potato chips, and their grease containment systems are marginally effective. And you can actually see right over here, there is, you can actually see the grease staining on the roof. So Andrew, what would you use for the membrane on this project?
Well, I think it's first, you have to consider some requirements that are kind of thrown upon you on the building code. As you move further south, there are restrictions and mandates that you have to use, quote unquote, a cool roof or a cool membrane. So using something like EPDM will kind of go out the gate. For chemical resistance, if you're really looking for the best of the best, I would use a KEE membrane. It's just far superior to anything else. There's quite a few penetrations on this roof too, and that it's a flexible membrane. You can do a lot with it to detail out, pipe penetrations and curbs and walls. Another option would be TPO. It is definitely a chemical resistant membrane, but it's really dependent on that exact makeup of the exhaust. So getting samples of that exhaust, you can actually send it in and get it lab tested and figure out what contaminants are in it, and work with manufacturers to see what membranes would work the best. But probably it's most likely would be a KE system on this would be the best. But yeah, then TPO after that.
And one of the systems that I've seen go down a lot is where you have a hybrid of that grease contamination blended with a high traffic environment, and really either one or two plies are modified underneath that KEE to really help build up the durability while also having that chemical resistance.
Yeah, it's a great system. I mean, it gives you a lot of redundancy if you do that. So.
Yeah, and just to add on a little bit, I think Andrew is spot on with the selection on this. Even with that said, going with the KE membrane, trying to put back grease containment systems that do work, that help keep the grease off the roof. It will help that roof age better, perform better, and then in these environments too, while not necessarily contributing to the breakdown of the membrane, if you can keep the grease off of the roofs, then that also reduce, pests from bugs and birds and other things, which a lot of facilities, like this are very sensitive to as well.
And drain maintenance and keeping that grease off the roof also reduces the amount of grease you get in your drain system, reduces your amount of some of the preventative maintenance as well.
Very good. So for scenario number 2, this is a educational site, and more specifically, it's an elementary school located in northern Michigan. And yet again, to go in a little deeper, this is actually over their gymnasium. So Chad, how would you select the membrane for this roof?
Well, up in the northern environments, almost the opposite of what Andrew said from, being down south. There's a lot more heating days than cooling days up north. So you would want to run some calculations, but generally speaking, a darker roof is better in northern environments. So depending on how the building is laid out and, what's in there, that color, this looks like it probably is currently an EPDM system. There's not a lot of penetrations on the roof, doesn't have a lot of roof traffic. A thinner single ply would probably work just well up there. I'm not quite sure if that would be in a severe or very severe hail zone. If it was in a very severe hail zone, then definitely durable cover board on there. A couple other things that would drive the membrane and the attachment of the membrane would be when it is a gymnasium roof, what is in that gymnasium? Is it just a basketball court, or do they have a pool and high heat and humidity? Also, a lot of gymnasiums are looking at sound deadening. So it could be a cementitious deck. A lot of people know them as tectum, or it could be a vented steel deck with fiberglass in the ribs. So depending on the deck type, the attachment could vary from mechanically attached to an adhered membrane. Those would be some of the big things that I would look at in the design and membrane selection for this particular building.
Alrighty. The next scenario is a equipment manufacturer that is located in Florida. The roof is over their machine shop, and their exhausts over their machines have a little bit of grease discharge. Jennifer, what would you use for a membrane here?
All right, so we know from the information that we're given that this is down in a hurricane zone. So we're going to have higher uplift pressures. We're going to have some hurricane parameters that we need to contend with. It looks like this is a black color to me, so it looks like it could be an existing EPDM or possibly a really aged modified bitumen roof system. But we know down there in Florida, it's hot. And so I'm thinking maybe something with some reflectance, either a single ply or a modified bitumen with some white granules. I don't see very many mechanical units there, but there are a couple, and they're saying that there's some grease discharge. So we're going to need to address that either with grease containment or special treatment around those mechanical units. So based on what we know, I would lean towards a single ply like a PVC or a KEE. Either would be a good fit, and that would also match the roof section that's just adjacent that looks bright white. That's probably a single ply. So yeah, probably a PVC or a KEE single ply Alternately, we could go with a modified bitumen with some special treatment around those grease producing units.
And with those large units, probably some special attention to extra protection around those with either, walk pads or different treatments as well.
Yeah. Yeah, maybe an acrylic or a resin system around those units to create an extra protection zone.
The next scenario is a hospital located in Chicago, and more specifically, this is over their operating room. Chad, how would you design the membrane here?
Well, this is a fun one. I've had the opportunity to do a couple of these, so they're very interesting. With the hospitals, and in particular over operating rooms, they can be very sensitive to smell and noise entering the facility. So with the technology that's out there right now, I would probably look at what could we do to limit noise and smells. So perhaps a self-adhering sheet. A lot of those nowadays too, they can go down in very cold temperatures, they can go down in colder temperatures than if you're using adhesives or polyurethane foams. So depending on the type of year, all three of those would work. Polyurethane foam ribbons with the fleece back membranes have low to no smell. You can get solvent free adhesives, water-based, that kind of like smelling Elmer's glue. There's virtually nothing there. And then with the self-adhering membranes, if you can keep the dust down and things like that, they adhere very well, as good as anything with adhesives on there. And one thing to consider when I said low odor, if you are in a low VOC area, low VOC does not mean low odor. Typically, low VOC means stronger odors. But if you do need to use an adhesive that has a smell, then on a hospital, in any facility, if you can put charcoal filters over the air intakes, that works very well. They're fairly inexpensive, and if you can get hold of the person doing the mechanical maintenance, often they can just buy that in bulk to take care of that. So especially in Chicago, they have a mandate, even though it's a northern climate, large city, they do like reflective roofs. So if it went EPDM, it would be white EPDM. That adds a little bit of cost to the project. So in this case, it probably would be PVC, KEE, or a thicker TPO membrane for that roof section.
Very good. The scenario number 5, this is going to be kind of an interesting one. So this is a corporate office located in Minneapolis. And you look at the picture and it looks like it's fairly new, white single ply. However, they recently had hail damage. So they need to replace the roof. But at the same time, they want to put in a vegetative roof to support their green initiative. Andrew, kind of talk through the membrane selection on this project.
Sure. So first things first, it's an existing building, so you don't have the opportunity to design specific structural scenarios into your building. So the first thing we always recommend is pretty much a structural survey needs to be done to make sure that your building can handle the additional load of a vegetative roof. It's going to be way heavier than that existing single ply roof that's sitting there. So you just need to make sure you have the capacity to carry that extra dead load. But besides that, if we were talking just membrane selection, I'm probably going PVC, TPO, KEE underneath this, something that you can heat weld the seams, potentially strip in if you wanted to, probably not necessary. But along with that, I would highly recommend installing an electronic leak detection system. Pretty much it's a wire system that gets put around or penetrations, the perimeter of your roof, and you're able to bring in a company that has some special equipment. They can hunt down leaks. I will get that roof tested before you put any of your vegetative overburden on, because it is very expensive, whether you have a tray system or just straight plants on your roof. It's really, really expensive to move that stuff and hunt for leaks. So there's a lot of steps to take for a vegetative roof, and it gets expensive. It's just, there's just more steps to it, and I really recommend following all those steps.
And our sixth and final prepared scenario is a mineral processing site located in Arizona. The specific roof that you can see there, that I have circled in red, is the raw material storage. So that's where they store the minerals after they've taken them out of the ground, and it's not very sensitive to moisture. So Jennifer, talk through the design here.
All right, so starting with what we know, we know this roof is in Arizona, so it's hot there. I've had the pleasure of being in Arizona in the summertime on a couple of roof projects, so we know that we want something reflective. I also know, based on Arizona, that they can be in a severe hail zone, surprisingly. Strangely, it doesn't seem like they would get hail, but they do get hail down there. So we need a system that's going to have a moderate uplift, able to deal with that heat loading, some reflectivity, and that hail resistance as well. I see very few penetrations on this roof, so I'm going to assume that it has low foot traffic. So, and it looks like a single ply membrane to me, bright white, either that or a coated something or other, but a bright white membrane is probably a good guess. And I would say going back with a single ply membrane would be my recommendation based on what we know. It looks like the outer edges might have a transite deck on them. If the client was considering re-roofing those as well, we could look into a spray foam or a spray polyurethane foam roof system over that transite deck to give them another new lease on that transite service life, extend that service life of those sections as well.
All righty, so thank you so much for everybody that's joined us and has provided so many great questions. So I'm going to pull a little bit of an audible with our panel today, and we're going to be going through a few other scenarios as well as a few other questions that I think are going to be really valuable. So thank you so much for all the questions that you guys have answered. They really are phenomenal. So let me come over here and take a look through here. The first thing that I'm going to do is I'm going to actually jump back in time to the roof membrane attributes slide. And so this question, they are asking, if you had to pick 3 criteria, which of those 3 do you focus in on? Obviously that's a general thought, but which 3 do you focus in on first?
Well, yeah, first, that's a good question and kind of open-ended. And with 3 designers, you got 3 different cooks in the kitchen that are going to give you different things. But primarily, depending on the client, durability is always a big one. Whether that is from roof traffic, just environmental durability. You want your roof usually to last a long time. Even if you have money to replace it, there's always the impact to replace that roof to the facility and to operations. So durability would definitely be one. Service life, the same thing. You would want that roof to be serviceable for a long time. And that can mean 2 things. That can be meaning it's serviceable through its initial installation, or are we building a roof where when it comes time to re-roof, we have a good base for a recover or a recoat, something that we can keep, sustainable. I guess
I think cost has to be one of your top 3, because you can't ignore how much things cost. You have to consider that you're designing something that someone can afford.
Andrew, do you have any thoughts on which 3?
Yeah, I agree. I mean, in a perfect world, we wouldn't have to think about cost and we would have an unlimited budget, but it's just not realistic. I think ease of installation is one that you want to think about maybe more than you would think. It's the more you set yourself up for an easier installation, the better results you're going to get, the better quality you're going to get out of your contractor. So that's definitely one I'd throw in the hat too.
Yeah, and it goes all the way to the design stage. And it means that we need to design things that are that people can understand what we want, and then the intent of our design is clear. That the drawings are not so complicated that they can't be built, and that goes back to the ease of installation as well.
So Jennifer, this next question I'm going to give to you, and it's going right back to that recyclable kind of line of questioning. And they're asking, should we request the roofer to recycle during tear-offs, or will they just do it on their own?
Well, they probably will not do it on their own. So we do request in our specifications that they recycle certain components just as a general rule, like pallets and plastic buckets. And there's certain items that are just roof debris that we expect them to recycle as a part of their normal course of business. If you're expecting them to recycle the membrane, you need to specifically ask that, yes. Some membranes can be recycled. Some manufacturers make it really easy. Some are a little bit more difficult to recycle.
Yeah, and there's a slight cost to recycling, and as Jennifer said, each manufacturer, some manufacturers will actually provide boxes or specific containers for the membrane to go in. Other ones require it to be cut into certain sizes and packaged correctly. So when it gets to their facility, it can be shredded and put back into possibly walk pads or other materials. So it is a good idea. There typically is a little bit of cost that is associated with that. Some of the easiest ones for the recycling are the metals, clean metals. A lot of times the contractor will do that on their own because, they get a little bit extra out of that.
Yeah, or copper. Anytime you see copper, they're going for the recycle with the pizza fund.
Yeah, I was getting ready just to say, back in the good old days when I roofed early on, that was always a great, exciting job when you pulled up and saw copper or something like that. You had pizza money.
Yeah. Yep.
This next question is yet again on that recycling front. Have you seen the request for recycling and sustainability information increase for these products, or is it more based on West Coast regulations?
I personally have seen it increase across the nation. The project that I was referring to with the zero landfill was in Ohio. And I've seen similar requests for recyclable products in Texas and West Coast as well, Oregon. So not just West Coast, but also throughout the nation, there's a couple different bigger companies getting on board with trying to be good stewards.
We have one more question, and then actually a couple scenarios that were submitted. So this last question, and this is going to be a little bit of yet another one that there's going to be some good discussion on. What membrane would you recommend highest alongside a robust cover board for Factory Mutual's very severe hail rated assemblies?
That's a tough one. I can start on that. So very severe hail is a new thing for people that don't know. FM Global came out with a new map, and it has a new cat. It used to just be moderate hail and severe hail, and they added very severe hail, which actually takes up a pretty good chunk right down the middle of the nation. It was very slow to get any assemblies tested. The first ones that came out were mainly modified, and I think the first single ply ones I think were TPO. But now there are some PVC ones, some KE ones coming along. It's really hard to just pick one though. It really depends. I mean, there's so many variables. Like Jennifer said earlier, paired with a good cover board, modified is almost bulletproof. But so if you're really, really concerned about hail, I would say modified.
Yeah.
Yeah, and if going to a single ply, if that's what's needed, then I think getting a membrane with fleece back, a fleece backing offers a little bit more protection. It absorbs a little bit more of that energy. So it kind of acts different than the modified. The modified is just strong enough to resist it. And the single plies typically need to absorb a little bit of that energy and dissipate it, so that fleece backing can help with that, or putting it down even in a polyurethane foam, which that'll add another small, maybe an 1/8 inch, 16th inch thick layer of almost insulation that would have a little give and absorb some of that energy as well.
Definitely the cover board is important to
Yeah,
prevent that permanent deformation of any of those
Yes.
sets. Even the
and this
modified
is,
bitumen, but single plies especially.
it's almost changing weekly now, but when these systems first came out and continue to come out, many of the single ply systems utilize OSB or plywood. I think mainly OSB as a cover board, so that's something we would not recommend. We do not like to put OSB as
No.
a cover board. The modifieds can utilize gypsum in most cases, but just something to look out if you are FM insured and you're in that zone. It's a concern, but it's getting easier as we
It
go
is
on
getting
here.
easier.
Yeah, getting much easier in membranes, and even just real recently, I think a new couple cover boards, gypsum, have come out that are specifically for the very severe hail. So, yeah, I think that's only going to get better, and that's good for the industry, and especially good for clients in very severe hail, that they won't be now limited just to a couple selections. They'll be able to, choose a roof that is right for their facility, not just right for the insurance carrier.
It'd definitely be interesting on that hail resistance line item if we were to change that to hail resistance without a cover board, seeing how much of a reduction in acceptable membranes would come out of it just without having that solid substrate.
Well, to put it in perspective, I was on a project recently for a hail evaluation, and then we had PVC membrane that was the same membrane for all intents and purposes, but one was fully supported by a cover board, gypsum cover board. The other one was over polyiso, and the dimpling and denting of the supported membrane was very minimal. It took the same amount of hail strikes on both roofs, but the dimpling and denting of the supported membrane was pretty minimal. The dimpling and denting of the unsupported or the over polyiso, we were seeing 1/2 inch to 3/4 inch dents. So it definitely it definitely means a lot to be supported by that cover board.
Yeah, we've seen similar, up north, just like you said, Jennifer. The ones with a good cover board were able to be repaired with pretty minimal repairs. And in this case, the one I saw, the hail actually went through the PVC, into the ISO. And I'm not just saying that it's PVC that was causing that. I think any other single ply, whether it was polyester reinforced or fiberglass, the hail was just that tough. It just blew through the membrane.
So as I mentioned, we had a couple scenarios that were presented to us last minute. And the first one is a high-rise building in Missouri. And so what I was going to do to help make the discussion easier, the hospital roof would have probably a similar appearance. So let's change this from being the hospital to being a high-rise building in Missouri. What would your guys' thoughts be on a membrane for that system, for that building?
Well, if it was just a high-rise building and you're looking at, a roof system, so there's not going to be any, traffic on it, you're probably going to want to look at ease of installation. It's very hard to get materials up onto a high-rise. Usually you don't want to bring in a tower crane. Oftentimes you have to. So you would look at what can you get in smaller roll goods, what products can you eliminate. Yeah, so possibly a self-adhering sheet would be good. Then you can eliminate adhesive buckets and things of that nature, less to blow around. But depending on access, you really could put about anything up there. But down in Missouri or down south, getting hotter. What do you think, Jennifer and Andrew? A lighter colored roof?
I would probably go with a lighter color, reflective. You're also, I think, in that very severe hail zone, or at least a severe hail zone in Missouri. So you're going to need something with a cover board to support it, fully supported. You need something with some flexibility. High rises tend to have a little bit more movement, a little bit more expansion and contraction, if you were. So yeah, single ply or something reflective.
Yeah, I would say if it's, I think an induction welded system could work out pretty well here too, because that eliminates the use of any adhesives or most adhesives. You have to hear your flashing still, but that just takes a piece of equipment to get done. So
Yeah, that's a good thought.
The one thought I have is with it being a high rise, that's definitely where having those wind calculations done and knowing for sure that your attachment, whatever system you decide, the attachment is adequate for the heights of the building, to me is really, really important. The next scenario that was presented was for a tilt-up warehouse in Louisville, Kentucky. And so for that one, I thought that this picture would be probably a rough equivalent. So now instead of being in Arizona, we're in Kentucky. And just for sake of conversation, we're just going to go ahead and say that it's a finished goods warehouse, so the interior occupancy is sensitive to moisture entry. What are your thoughts on a membrane here?
Typically on a warehouse, not a lot of penetrations, so not a lot of foot traffic, so you wouldn't have to go nearly, as thick. And I don't think they're in very severe hail, just severe hail.
Just severe hail, I think, yeah, for Louisville.
yeah, sounds right.
And I would lean towards a TPO membrane, given usually the vast square footage of some of these finished goods warehouses, and like Chad said, the low foot traffic, relatively few penetrations. It might be a good solution for a TPO membrane. Yeah, that would be my first look at it.
Yeah, and the reflectivity of the TPO would be really good as well. A lot of times the warehouses, they're so vast that they don't do a lot of heating and cooling, so you're really, whatever the temperature is and heat beating down on the building, so you want to reflect that heat away to not make an oven in the summer, which happens quite often. So I think that would be a very good option.
I'd probably avoid the modified bitumens. If it's a low slope, the metal roofs might not be a good solution for it. So I could rule out EPDM, black EPDM, rule out modified bitumen, rule out metal. So that leaves you with the single ply families, and knowing that knowing these typically are vast, huge roof areas with few penetrations, I think it's a good fit for TPO.
And, I think too, you could possibly look at, depending on how, big it is, we also know ballasting is still out there for different roof systems. The benefit of ballast is that, it's quick. Kind of the downfall of ballast can be, though, that when you get a leak, it's very hard to find the leak. It's, go to the inside of the building, measure off where the leak is, go back up to the roof, and start moving rock in that area until you find it. A ballasted roof could be, another good option for that.
And actually, one of the questions that we were asked were, what are the benefits of a ballasted roof? And Jennifer, with you being down south, do you want to talk a little bit about using ballasted along the coastlines?
Yeah, we don't do a whole lot of ballast near the coast for hurricane reasons and for uplift reasons. A lot of times to get the uplift ratings that you need, the ballast is just not heavy enough. And if you were to use a heavy enough ballast to get that uplift, you would have to structurally upgrade your building in order to put that much rock on the roof. In addition, that rock can become a flying object or flying debris, and that's a bad thing. So you don't really want to put ballast near the coast. I do like ballasted roofs. I think that the benefits to a ballasted roof, especially like, for instance, when you're dealing with a re-roof assembly where you've got maybe some lightweight aggregate concrete that is suspect. You don't know how it's going to do with adhesion. You can't screw down through it. You can ballast an EPDM system or ballast a single ply system fairly simply on that roof and get that roof watertight quickly. So there are definitely benefits to it.
Once again, thank you guys for all of these questions that have been submitted during the webinar. Like I mentioned at the beginning, we do have a few that were submitted beforehand. So we're going to try to get through those, but I see we only have 5 minutes left. We might not make it through there. Feel free to keep submitting questions, and anything that we don't get to, we will make sure to follow up with you individually and make sure that every question is answered. So the first question was, explain how cost should be included in the selection process. And Jennifer, you kind of touched on that already. Is there anything else that should be added to that?
No, I think cost is a factor. I don't think it's the most important factor, but it definitely is a factor. If we don't think about the cost at least, or consider the cost, we can design roofs that can't be built, and that's not good. So.
The next question is, what criteria do you use to determine the mill thickness of a single ply membrane? And we'll just assume they mean during the design phase. And Chad, would you like to answer that one?
Yeah, a couple things are, you know, with the mill thickness is how long do you want your roof to last? You know, every type of membrane loses a little bit of thickness and millage over time. So generally, the thicker the membrane, the longer it's going to last. Also, membrane thickness usually adds to durability. I think that question was, you know, asked as well. So if you're going to have roof traffic or maintenance on the roof, you're going to have inadvertent tools being dropped, metal access doors drug across the roof. So if you can just scratch down, say, into a 90 mil membrane, maybe the first 20, 30 mils, you still have a full membrane left underneath there. So items like that, you also want to look at UV degradation. Down south, you probably want a little bit thicker membrane than you do up north for that. Typically, you know, now I'm almost jumping back to the first one, but EPDM and TPO, about a penny a mil. So it doesn't add a huge cost if you're just talking about increasing the thickness of the membrane. But if you have a very large warehouse roof, then increasing that thickness does increase cost.
The next question is EPDM a good roof membrane? And Andrew, go ahead and answer that one for us, please.
Short answer, yes. Not so short answer is it's really, I mean, it depends. Are you in the South? Then I would say no. Do you have a lot of grease contaminants coming on your roof? I would say absolutely not then, because EPDM does not do well with grease. But overall, EPDM, I think it's a fantastic product. Especially in northern climates. I mean, it's very flexible. Leaves you a lot of options to detail stuff with different self-adhering sheets. They have their field membrane you can self-adhere, and it works really well. There's just a lot of different options with it, and that's kind of why I like it. But there's no magic bullet for a roofing membrane. There's not a one size fits all, so it's just depends.
The next question, Jennifer, is what membranes have a strong history of excellent performance?
All right. I would think all of the membranes we've discussed today have a strong history of performance. Some of them have gone through some product redevelopment, some shifts in the manufacturing processes and chemical compositions, but all of these are strong performers and have a strong history. Your oldest membranes are obviously your built-ups and your coal tar pitch that we're seeing those go by the wayside somewhat. Next in line would be the modified bitumens with the longest track record of the ones we've discussed today. But then next you've got the single plies, and most of these single plies are about the same age and same general good track record. TPO, I will mention, has gone through some challenges, but they've come out of most of those, I think, and are on the track record towards success. So I think we're seeing some longer standing TPO roofs and some longer performing TPO roofs now with the new formulations.
Very good. And actually, the next question was actually kind of touching on that, so we'll be able to go ahead and skip through this question. And the last question is, what is the most installed membrane?
At this point, especially new construction, TPO is like far and ahead of everyone else. Re-roofing, I'm pretty sure they're probably the leader, but it's a closer field with re-roofing. I want to say they have like 27 or 28% of the share. So
definitely single ply as a whole, single ply membranes.
Yeah,
Yeah.
Very good. Well, as I mentioned, that was the end of the prepared questions. I see we do have a few others that we need to go ahead and answer outside of the webinar. Thank you so much for joining us. After the recording gets processed, I'll be sending out a link, and as well as soon as I hit end, a survey will appear letting you know your thoughts on how we did, as well as a chance for you to recommend future webinars for us. So thank you once again for joining us.